Waste papers and leaves are a common sight around us. Soon, the technology to use these to make a capacitor that stores energy will be available to us. Researchers of CSIR's National Chemical Laboratory have created such a supercapacitor. Here is a report.
While on the one hand the country is grappling with increasing demands of clean energy, on the other hand, issues like effective disposal and recycle of waste is an issue. Under such circumstances, how wonderful it would be if one could link both and have a mechanism for generating energy using waste like paper. Soon, such a technology will be available to us in the form of a supercapacitor which uses waste paper to store energy. This innovative product has been developed by the researchers of CSIR's National Chemical Laboratory located in Pune. Capacitors are small devices used in electrical circuits to store energy. While traditional batteries take longer time to charge and use chemical reactions to store large amounts of energy, capacitors store energy in an electric field and can charge and release energy quickly. In order to increase the capacity and speed of currently available capacitors, scientists are building supercapacitors using forms of porous carbon that can suck up charge like a sponge. CSIR NCL's novel supercapacitor is a major innovation in this context in which waste paper is turned into a super sponge battery. The product has been developed by Dr. Satish Chandra Ogale of NCL and his team.
Here we are trying to develop energy storage devices, particularly the supercapacitor, which can store a substantial amount of energy density, and it is also able to deliver power at a very high rate. We are trying to use various waste sources such as sugarcane bagasse, waste paper, or even dead leaves to make a high performance carbon material for this application.
The researchers cut waste paper into small strips and put them through a series of heating and cooling processes, including mixing the strips with sulfuric acid at 180 degrees Celsius and carbonizing them at 800 degrees Celsius. After going through the processes, the waste paper becomes a form of carbon with microscopic structures that gives it a massive surface area for holding charge, more than 2300 square meters per gram. The team then used this carbon and an electrolyte gel to create a supercapacitor.